Hello, everyone. Glad to be speaking to you again in a different building. The theme of today was really how do you make operations simple? And the focus had been both on the software and the switches. How do you architect them better, properly? And then operational simplicity that you can derive by external systems, managing and configuring and provisioning these devices. So perhaps if we kind of look back, we are starting the fourth decade in this new networking regime. We started out in the 1990s, our first decade of sort of internet class networking, right, with TCP/IP, L2, L3, Ethernet, HTTP. We got connectivity. We all got connected through the internet. And then the decade afterwards, the 2000s, the cloud guys said, hey, this is not scaling for me. I got to have multi-tier leaf-spine architectures. I got to have programmability so that I can manage this infrastructure better. And custom silicons, I get this feature disparity. I need some consistency in features, and so merchant silicon-based systems emerged. Doesn't mean that architectural innovation stopped. They have continued. I mean, we've had VXLAN, BGP, EVPN, VXLAN, and a variety of things have come since then as well. But if you look at just that portion, if we kind of look at what Metcalfe said, Metcalfe's law is, just like Moore's law, we have Metcalfe's law. More systems connect, the value of the network increases, right? Fantastic. But there is a Metcalfe conundrum, which is when more systems connect, the network becomes bigger. It has more devices. And if each one of those devices is operating independently, then what happens to complexity? It also proportionally increases. And so how do we bound that complexity? By extracting physical from logical. And that's where the last decade, a lot of effort has gone in to bringing operational intelligence. And you saw a lot of that demonstrated today, right? But it started out with folks leveraging Chef and Puppet and Ansibles, and now custom operational systems like CloudVision to be able to simplify and automate the operation so that you can bound the complexity and get out of the Metcalfe conundrum. And it's a feedback loop. So it's not just that I'm provisioning something, but I'm making a change. I'm learning from that change. I'm understanding that change. And I may have to recalibrate. And for example, upgrade is a great example. If I were to apply the upgrade and there's an issue, I need to roll back. So the question is, what's next? We are in a new decade, 2020. So what's in it for us? And of course, none of us can predict the future, right? But we can take a bet. And your bet may be different than somebody else's. But here's one bet. And what we're saying, contextual intelligence. And what does contextual intelligence mean? Can I understand the context of the network? And it's not just the network itself, but what connects to it, which is virtual machines, containers, other systems, users if I'm on a campus, IoT devices. And can I capture this information? Can I analyze this information? Can I learn from that? Predict future behavior by baselining it, temporally agnostic, so that if something happened on Mother's Day, it's different from something happened on a rainy Sunday. And can I even, not just NetOps, but can I even help SecOps people? And can I help with security? Can I make SecOps life easier. And so the problem we are trying to address is, one is, Ken talked about, the call at 4 a.m. in the morning with 2 switches, having a very old code. And you can do that with operational intelligence. Very quickly, you can look at what your 500 switches are, and it can, in fact, alert you that you're not on the recommended release. Fantastic, we have achieved that. But what about when a server BIOS upgrade has a bug, or that the server CPU is operating at 90% util 90%, it's 90% hot, and the app is not working, and who gets the first call? It's a NetOps. We had a situation where a customer had deployed the solution, and the power supply, there was a firmware upgrade, and the power supply code had a bug, and the servers were intermittently crashing. They were not crashing, but the applications were not performing properly, and the blame was on the network. It was a 2-day cap case, and then we finally found out that it was actually the server team missed the fact that there were all these syslog messages coming about the power supplies, and they were not picked up. And it was because, oh, it's a network problem, it's a connectivity issue, solve that first, right? And so can we get the context about things that connect to the network? Because oftentimes issues are there as well. So one is, really, is it app or the network? And the other is, can I fix security issues faster? So how do we address this? And it turns out that you can address it with a network that sits parallel to your connectivity network, a network that connects applications. And we've never thought of it as a network, but it is called an out-of-band network built with a product called Network Packet Broker. It's called a visibility fabric, a monitoring fabric, however way you want to term it, but it essentially gets a replica of the traffic from the main network, and then brings or understands that traffic, provides context to that traffic, and then sends it to appropriate tools for deeper analysis. So they can be application performance monitoring tools like ExtraHop. They could be security tools like Radware and others. It's turning out that almost every enterprise is now needing monitoring. Monitoring is becoming mission critical, in fact. And there are a variety of tools within an enterprise where each tool owner needs access to a set of data in order to determine whether the service they're providing is correctly running. And so there are NetOps tools, there are SecOps tools, there are customer experience monitoring tools, there are risk management tools. And so monitoring is not just becoming mission critical, it also needs to become a service that is offered to a variety of stakeholders. And so one of the ways to achieve this is, as I said, building that monitoring fabric next to the production network. And this is where Arista's DANS has, for example, been a capability that has been available. And now with the Big Switch acquisition, the monitoring fabric that Big Switch brings sits right in that space with additional capabilities. So the question now becomes is, am I monitoring or am I bringing context? And so for that, you need one additional technology building block. If you look at context, today traffic is going over networking devices that are built with, say, Broadcom silicon or networking silicon. Networking silicon process data, typically L2, L3 headers, maybe some additional deep packet inspection. But that's about it. So how do you get context? You have to capture all the traffic, and then you have to analyze that traffic. How do you analyze that traffic? You can only analyze that traffic in x86 processors, servers. And so when we want to bring context, these devices need to process data on x86 servers. Now, again, the problem now becomes is if I have those, then how do I manage them? And so the management systems or network systems now needs to be such that you have a set of networking devices, switches, and routers. And you need to have x86 devices that operate on packets and flows in order to provide context. And so what does that mean? So with Big Monitoring Fabric, the solution that is brought as part of this acquisition, there are three smart nodes, three types of smart nodes. One is what we call a service node. A service node essentially analyzes all the packets and can offer a variety of services. For example, if you capture packets from a variety of places, you would get duplicate traffic. If you send duplicate traffic to IDS, your IDS is overwhelmed, or any other tool. So one of the important service that is needed is to deduplicate the packet. You can do that at high speed with DPDK service nodes. Header decap is another example. Some of it you can do it in switches. Some of it may not be available, which you can do in x86 node. Netflow generations. Many, some ASICs are able to do that. Some switches, many switches are not able to do that. They can only generate NetFlow. How do you generate? They can only generate SFlow. How do you generate NetFlow? And these service nodes can do that at very high speed. So by clustering, providing a clustered set of intelligent nodes, smart nodes, connected to a network, managed through a same entity, is now able to provide a very flexible processing to bring context in what we do. So that's one, is ability to process packets and flows. What about recording them? If we are going to ask for whether it's an app problem or a network problem, and what happens at 4 in the morning, we need to rewind the network state. How do we rewind the network state? We can only rewind the network state if we have captured the network state. And so recorders become part and parcel of a network system, where you're recording traffic, storing it, not just traffic, but packets, but flows, network states, device states, so that you can go back to 4 in the morning and say, this was the state of the network. And let me now replay that state of the network. And this is the way to simplify troubleshooting, make us get to issue resolution faster. And if we are also capturing traffic or information from virtualized systems, from hyperconverged systems, then now we can correlate IP addresses and MAC addresses, which is what the network sees all day long. The network only sees IP addresses and MAC addresses. Can we associate names to that? Can we associate the host to that? Can we associate the CPU utilization on the host to that and bring that additional context to be able to do issue resolution? So recording becomes, as part of this evolution, recording becomes part and parcel of a network system. You want to record, you want to query fast, and you want to have it associated with applications so that you can actually understand transactions. You can understand that this is HTTP GET versus HTTP POST and be able to do analysis on that. What else? The next item is analysis. How do I analyze this data? So I have ability to process packets and flows. We have ability to record them. But can I have intelligent way to understand what is happening? And this is what happens with the analytics node. And so these three nodes work in harmony together along with the network system to be able to provide a very rich context about what is happening in the network. So what does analytics node do? You can now have historical information. You can have real-time information. You can associate IP and MAC addresses to host names, VM names, container names, and be able to talk intelligently with the virtualization team, with the cloud team within an IT organization during a debug session. When one is doing an upgrade or doing an application migration, what is the dependency of an application with other applications? The application dependency mapping makes it very easy to identify whether or not application that you're retiring or migrating is going to cause problems with any other applications that are in production today. And finally, ability to learn from the data. Just syslogs, if we can learn from syslogs, because there are so many with different severities, if there is an intelligent way for us to just sift through that and have it analyzed by a machine and tell us the right things, important things that we humans should be thinking about. And that's where capabilities such as machine learning, when added to analytics, can help us better understand the state of the network, what it is today, what it was yesterday. So, in summary, one of the important aspects of the acquisition is the monitoring capabilities that Big Switch has built that is completely complementary and enhances the DANS portfolio that Arista has. And we look forward to bringing this over to Arista.
All right, let me say one thing real quick. I've had the pleasure of working with this man for about 21 years now, dating myself.
Thereabout.
Yeah, roughly, since '99, and it's awesome to be back working with you again on this. We're really just tremendously excited to work with the Big Switch team. I think they've built an amazing set of products and capabilities that, in many ways, have inspired our market. We look at SDN and what's going on there, and whether you look at SDN as a segmentation technology or a provisioning technology or an automation technology or a cool acronym you want to put in front of everything to do with networking, Big Switch has been at the forefront of leading a lot of the initiatives and the innovations that have happened in the software-defined networking space. When we looked at possibilities of integrating and becoming one company, we said, first off, how do the people, who are they? How do they fit in? And it was so obvious. The team is amazing. And to be able to work with them again is just, to me personally, super cool. The products fit really, really interesting places. And Prashant talked about the big monitoring fabric. And every production operation shop we talk to, which is financial services, gaming, SaaS, semiconductor, healthcare, clinical, federal, defense, you name it. Those networks, the uptime and reliability of those, the ability to monitor those is just as important as the ability to transit packets north, south, or east, west, or whatever direction you want to throw it. If the monitoring stops, the information security team's visibility stops. Employee relations stops doing some of their jobs. How do you know it's up, right? If you, what was it? The guy said if you can't measure it, it didn't happen. Dale Carnegie or one of those management consultants. And it's becoming a critical service. We had a really cool capability there that integrated with our switches, yet what Big Switch built is so much more. To make that a multi-stage fabric with central provisioning. I mean, can you imagine the workflow and just how awesome it will be when you're on, like, Carl's sitting here on, Cloud, Wireshark or Bro, which is the worst name ever for a product. Sorry, guys. But it says, just get the traffic from user D, give me the next 100 packets from user D Gourlay wherever that user is on the network. And the network gets it and delivers it and stores it and analyzes it and puts it right in his tool. And he didn't have to change tools. Didn't have to change pages. Didn't have to go plumb a connection, map something, do a span session, filter it. All of that happened automatically. That's what this enables. And it's an amazing game changer for people who run production shops.
If you're using Bro, for example,
yeah,
your view is, I'm thinking of community ID, which is the flow spec for a given given flow. And your context is community ID. Can you use community ID to capture packets from a recorder node and get a PCAP and deliver to you as a service? You don't need to know anything about the network. You just want that information. But your context is community ID, and you want to communicate that information to the recorder node and get the information. And this allows you to do that by providing monitoring as a service, recording as a service, through understanding the context of each other's domains.
And then I look at the Big Cloud Fabric, a tool that's been delivered through incredible partners like Dell, who was involved in the press release that went out today announcing the acquisition. Big Cloud Fabric lets us take a structured topology and manage it as a big network, not a collection of devices. And then imagine a VMware environment, a VxRail environment, a Nutanix environment, OpenStack, Kubernetes. You build virtual private clouds, the same unit of consumption we use in public cloud today, using the same APIs on top of that infrastructure. I want a VPC via Terraform in the cloud. I build a VPC in Terraform. I want it on my cloud fabric. I build it in my cloud fabric. And then we connect it to a system of record. VMware, Nutanix, as they provision workloads into that network, the network dynamically adapts to the platform team's requirements. It's a completely different operational paradigm than we're used to in networking. Config T, changing things in boxes, twiddling bits. No, the bits twiddle themselves based on what the platform team needs, which is why it is a perfect product for us to continue to deliver and support through amazing partners like Dell, Mavenir, and others. Now, that's probably the most I can say up front, unless we get specific questions about what some of our plans are of integrating these products. Like I said, we had just announced the acquisition today, and we purposefully timed this session with all of you to be after that announcement, so we could take a couple questions, but also please respect, we don't have all the answers yet, and we don't want to rush to those answers either. We want to make sure we take the time to understand all of the clients' use cases, what great benefits they're getting, what they'd like to see us do from an integration effort, and then make really well-informed decisions about that.